Okay guys, so nandito na tayo ngayon sa part 2 ng ating lecture about Biochemical Oxygen Demand or BOD. So sa lecture na to, we are going to solve problems about BOD. So itong apat na problem na to yung sasagutan natin. No? So isa-isahin natin siya. So sa previous video natin, napag-usapan natin itong mga formula or equations na gagamitin natin in calculating for the BOD and the ultimate BOD. So, in-explain na natin yan sa ating previous video, no? So, kung hindi nyo pa napapanood yon, so, we are advising you to watch that video first para maintindihan natin kung ano ba tong mga ginagamit nating terminologies dito, no? But on this video, we're going to apply itong ating mga equation dito in solving problems, no? Ito yung ating formula for getting the BOD5. And this is our formula for getting or estimating the BOD removal over time, no? So let us try to solve this first problem. A sample of sewage from a town is found to have a BOD after 5 days or BOD5 of 160 milligrams per liter. Estimate the ultimate BOD of the sewage, assuming K is equal to 0.1 per day for this wastewater, no? So, given sa atin dito yung BOD after 5 days and that is the BOD5. Okay, so our BOD5 is equal to 160 milligrams per liter. So, since this is a BOD5, that means our time is equal to 5 days. Now, our requirement is to determine the ultimate BOD, which is LO, no? So, ito yung ating kailangang makuha. So, we're going to apply this formula right here, in which our BODT, okay, our BOD at any time t, is equal to the ultimate BOD times 1 minus E to the negative KT. Okay, so, direct substitution lang to guys, no? So, ang kailangan nating makuha is yung LO. Now, our T is equal to 5. So, our given here is BOD5, which is 160 milligrams per liter. And this is equal to the ultimate BOD times 1 minus E, okay, to the negative KT. So, what is our K? Our K is 0.1. No? So, let me change this to a bracket, no, para hindi tayo mahirapan. So there's going to use a bracket here, and then we have here negative. Our K is 0.1 per day, and times our time, which is equal to 5 days. Okay, so kailangan nating masolve itong ating LO. So we have 160 is equal to LO times, let us solve for this value, no, itong nasa loob ng ating bracket. Okay, so let's use our calculator. So, unahin ko muna i-solve itong ating exponent ng E, no. So, we have 0.1 or we have negative 0.1 times 5. Okay, so yan ang ating exponent. We have negative 0.5. So, yan ang exponent ng ating E. So, let us get that, our E raised to our answer previously. So, we have 0.6065. Okay, so we have now 1 minus itong value natin. So, 1 minus our answer is equal to 0.3935. Okay, so therefore, our LO is equal to 160 divided by 0.3935. So, our LO or our ultimate BOD is equal to 160 divided by our previous answer, which is 406.64, no? So, we have 406.64 milligrams per liter. Okay, so check natin ulit. 406.64 milligrams per liter. So, that's our final answer, no? Nakuha na natin yung ultimate BOD. Now, I want to tell you something na maaring ma-confuse kayo. Kasi itong formula ng ating BODT here, okay, so let me write that here para kayo walay. So ito yung formula natin, no? Our BODT is equal to LO times 1 minus E to the negative KT, di ba? Ngayon, if you're going to look at other books, no, yung ibang references natin, makikita ninyong formula is like this. BODT is equal to LO times 1 minus 10 to the negative KT. Okay? So, meron tayong dalawang equation na makikita in different books. No? So, yung ibang books, gumagamit ng itong reference na to. Yung iba naman, ito ang ginagamit. Well, pareho lang yan guys actually, no? Ang pinagkaiba lang, nag-iiba yung value ng ating K. Yung small letter na K, this is used for reaction rate, constant in base E. Okay, so katulad niyan. Itong given natin dito, small letter K. So, ang ginamit natin dito is yung base E, no, sa ating equation. But sometimes, you will see our K is written in capital letter, no? So, ito naman, ginagamit natin yung reaction rate natin, which is having constant, which is base 10. Okay, so, pero maging maingat pa rin tayo kasi it depends on the reference books na ginagamit natin, no? But, some books, they are specifically mentioning this. Kapag may small letter K tayo na ganito, you have to use itong equation, that is having base E. Yung meron namang capital letter K, you have to use our equation having base 10. So, ano yung relationship nila, no? So, you have to take note of this relationship. Our K, which is the small letter K, is equal to 2.303 times yung capital K natin, no? You have to take note of that relationship. Okay? So, makikita nyo to sa iba't ibang reference books, no? Kasi minsan makikita ninyo pag nag-research kayo, magugulat kayo, ang base nila rito is 10, not E. Okay? So, you have to take note of this relationship. So, gawa tayo ng example niyan. Mag-solve tayo ng problem para makita natin yung use nitong capital and small letter K na ating reaction constant, no? Reaction rate. Okay, so we have a problem here that says if the BOD3 of a waste is 75 milligrams per liter and the K, so take note, capital K meron tayo dito, is 0.150 per day. What is the ultimate BOD? Okay, so gawa muna tayo ng solution number 1. No? Solution number 1. So, our K here is capital, no? Sabi natin, if capital lang ating K, we will be using base 10 sa ating equation, no? So, let us write our equation. So, we have BODT is equal to LO times 1 minus 10 negative KT. Okay? So, ito yung gagamitin nating equation. And as you can see, base 10 ang ginamit natin, ano? So, our T is equal to 3. Diba? Dahil 3 days lang, BOD3 ang meron tayo dito, no? And then, BOD3 is equal to 75 milligrams per liter. Of course, our capital K is equal to 0.150 per day. Okay, so substitute na natin yung mga values natin, no? BOD3, okay, so we have BOD3, susulat na nga natin, is equal to LO times 1 minus 10 negative K times 3. No? Yun natin bracket yan. Okay, so substitute na natin. Yung BOD3 natin is 75 this is equal to our ultimate BOD times 1 minus 10 to the negative, yung value ng ating K, yung capital K, which is 0.15 times our time, which is 3. Okay, so calculate natin yung values nitong nasa loob ng bracket. So we have 75 is equal to LO times itong value ng nasa loob ng bracket. So solve natin. So katulad ng ginawa natin kanina, no, unahin ko ng exponent. So we have negative 0.15 times 3. Okay, then ang base natin is 10. So I will have this 10 and yung answer natin. So we have 0.3548, no? Then we will have 1 minus itong answer natin. So 1 minus our answer. So we have 0.6452. So therefore, our ultimate BOD is equal to 75 over 0.6452. So our ultimate BOD is equal to 75 divided by our answer, which is 116.24 milligrams per liter. Okay, so yan ang ating sagot. Yan ang ating ultimate BOD. Okay, so now let's go for another solution. We have solution number 2. So, ang gagamitin natin is itong ating equation with base E. Okay? Pero hindi natin pwedeng gamitin yung K value na to. Dahil yung K value na to, yung capital K, ginagamit natin if our base is 10. Okay? So, para magamit natin itong ating equation, which is BOD T is equal to LO times 1 minus E to the negative KT. Para magamit natin yan, yung base E, kailangan yung K natin is to be converted dito sa small letter K, no? So, alam natin yung value ng big K, no? So, we have here K is equal to 2.303 times yung ating K, which is 0.15 per day. Okay, so therefore, our small letter K is equal to, let's solve for that. We have 2.303 times 0.15. So, this is equal to 0.3455 per day, no? So, yan ang ating gagamiting K. Yan yung ating small letter K. So, gamitin na natin yung ating equation. BOD3 is equal to LO times 1 minus E to the negative KT, no? Okay, so substitute natin yung mga values natin. Yung BOD3 natin is equal to 75 times LO times 1 minus E to the negative, ano yung ating K? So, yung small letter K na, no? 0.3455 times time, which is 3. Okay, so 75 is equal to LO. Then, multiply natin dito sa value ng ating nasa loob ng, itong expression natin na nasa loob ng bracket, no? So, let us try to solve that. So, unahin uli natin yung ating exponent. Negative 0.3455 times 3. Okay. Then, that will be the exponent of our E. Then, we will subtract this to 1. Okay, so we have 0.6453. Therefore, our LO is equal to 75 divided by 0.6453. So, our LO is equal to 75 divided by our answer. So, this is 116.22 milligrams per liter. So, pareho lang yung answers natin, guys, no? So, solution 1 and solution 2. So, dito gumamit tayo ng base 10. Dito gumamit tayo ng base E. Okay, so iti-take note lang natin itong formula nila, yung relationship ng ating K. Okay? So, I hope malinaw sa atin yan. Now, let's go to problem number 3. Okay, a wastewater was analyzed using 5-day BOD. Okay, so meron tayong BOD 5 dito. Given the dilution ratio of 1/800 milliliter wastewater per milliliter of BOD bottle, no? So, this is bottle, sorry. So, sulat natin para hindi tayo malito. So, we have dilution ratio. So, we have our dilution ratio, which is equal to 1/800 milliliter of wastewater per milliliter of BOD bottle. Okay? So, yan ang ating dilution ratio. Now, calculate the BOD after 5 days. So, pinapahanap sa atin yung BOD 5. And determine the ultimate BOD. Okay, so hanapin din natin yung ultimate BOD. If the dissolved oxygen initially measuring 10.26 milligrams per liter. So dissolved oxygen initially is equal to 10.26 milligrams per liter. Is reduced to 7.45 milligrams per liter. So our DO after 5 days is equal to 7.45 milligrams per liter. So, after incubation ng 5 days, our DO has been reduced to 7.45 milligrams per liter. So, the rate constant based on the experiment is 0.23 per day. Okay? So, our rate constant, K, is 0.23 per day. Assume this does not vary along the temperatures 20 to 30 degree Celsius and the same temperature persists in the sample and source. So hindi nagbago yung ating K value, sabi dito sa ating problem, no? So ang gagamitin natin formula dito, itong napag-aralan natin last time. BOD5 is equal to initial DO minus DO5 over our dilution ratio, no? So, we have BOD5 is equal to initial dissolved oxygen minus the dissolved oxygen after 5 days and our dilution ratio. So, substitute natin yung mga values natin, no? So, BOD5 is equal to our initial dissolved oxygen, which is 10.26 minus our dissolved oxygen after 5 days, which is 7.45, divided by the dilution ratio, which is 1/800. Okay? So, base dyan, makukuha na natin yung BOD5. So, ano yung value ng ating BOD5? Let's calculate. So, unahin natin itong ating numerator. We have 10.26 minus 7.45. Okay, so we have 2.81. Okay, so we will divide that to 1/800. So that means we will be multiplying this to 800. No? So we have 2,248 ppm. 2,248 parts per million. Okay, so yan ang ating BOD5. Okay, so nasagutan na natin tong unang requirement. Now, the second requirement is to find out kung ano yung value ng ultimate BOD. Okay, so gagamitin natin yung ating formula using our base E, no? So we have BOD5 is equal to LO times 1 minus E to the negative KT. Okay, so ano yung BOD5 natin? Our BOD5 is 2,248, which is equal to LO times 1 minus E to the negative. Our K is 0.23. Okay, times our time, which is 5, because we have BOD5 right here. So we have 2,248 is equal to LO times, calculate ulit natin ito. So, unahin natin yung exponent natin. So, we have negative 0.23 times 5. Okay, so that will be the exponent of our E. So, we have 0.3166. So, we have 1 minus our answer here. So, we have 1 minus our answer. So, we have 0.6834. So, therefore, our LO is equal to 2,248 divided by 0.6834. So, our LO is equal to 2,248 divided by our previous answer. So, we have 3,289.61. Okay, so 3,289.61 ppm. So, yan ang ating answer. That will be our ultimate BOD. Okay, so proceed na tayo sa ating final question, no? Itong problem number 4. Okay, so basahin muna natin yung ating problem. A waste is being discharged into a river that has a temperature of 10 degrees Celsius. What fraction of the maximum oxygen consumption has occurred in 4 days if BOD rate constant determined in the laboratory under standard condition is 0.115 per day, and mention dito that it is for base E. So that means this is the value of our K, yung small letter K natin, because this will be in base E. No? Our K is 0.115 per day. So this is base E. So ang kailangan nating makuha dito is yung fraction of the maximum oxygen consumption that occur in 4 days. Okay? So, basically, ang kailangan nating makuha dito. So, yung ating formula, di ba, is BOD. T is equal to ultimate BOD times 1 minus E to the negative KT. Para makuha natin itong fraction of the maximum oxygen consumption, so it is actually the fraction of the BOD over the ultimate BOD. So, we have BODT over our ultimate BOD is equal to 1 minus E to the negative KT. Okay, so makukuha natin yung fraction by solving for this. Kaya lang, ang given natin ditong K, actually, is done in the laboratory under standard condition. So, ano ba yung standard condition natin? Napag-usapan na natin yan sa ating lecture, no? Yung standard condition natin is to incubate our sample at 20 degree Celsius, no? So that means our K here, okay, our K is measured at 20 degrees Celsius. But it will be discharged in the river where the temperature is equal to 10 degrees Celsius. So iba yung K value niya, no? Dahil itong kinek natin sa laboratory is 20 degrees Celsius, samantalang yung river naman is 10 degrees Celsius. Okay, so dito natin i-apply yung pinag-usapan natin sa ating lecture video previously. And if you remember, we have this formula. K prime is equal to K times theta T minus 20. Okay? So, our K here, itong K na to, is yung ating K value at 20 degrees Celsius. Yung temperature naman natin is yung temperature in degree Celsius. So, recall natin kung ano yung value ng ating theta, no? So, sabi natin, if our temperature is equal to 20 degrees Celsius to 30 degrees Celsius, our theta is equal to 1.056. If our temperature is less than 20 degrees Celsius, then our theta is equal to 1.135. And kapag temperature naman natin is greater than 30 degrees Celsius, our theta is equal to 1.047. So, in this case, ang temperature ng ating river is 10 degrees Celsius. So, it is less than 20 degrees Celsius. So therefore, our theta for this problem is equal to 1.135. Okay, so our K prime is equal to our K, ano yung value ng K natin, at 20 degrees Celsius, 0.115 per day. So 0.115 per day. Okay, times our theta. So ang theta natin is 1.135. Then raised to T minus 20. So our temperature is 10 minus 20. Okay, so therefore our K prime is equal to 0.115 per day times 1.135 to the negative 10. So, solve na natin yung value ng K prime. So, our K prime is equal to, unahin ko na to, no? So, ganyan kasi ako mag-solve. Inuuna ko yung nasa loob ng mga bracket. So, we have 1.135. Then, ang exponent natin is negative 10. Okay? So, we have 0.28186. So, we will multiply that to 0.115. This is equal to 0.0324 per day, no? So, may value na tayo ng K prime. Tama ba? 0.0324. Okay? So, yan yung value ng ating K prime. Now, ito yung kailangan nating makuha. Yung ratio ng BOD4 over the ultimate BOD. So, we have 1 minus e to the negative our K prime. Our K prime is 0.0324 times our time. So, this is BOD4. So, our time is equal to 4 days. So, our BOD4 over the ultimate BOD is equal to, let us solve it in our calculator. Okay. So, we already have this. 0.0324. Multiply natin siya sa negative 4. Okay. Then, we'll take that as an exponent of our E. So, we have 0.8784. Then, we will have 1 minus our previous answer. So, we have 0.1216. Okay, so this is our final answer for this problem. Okay, so this concludes our lecture video about BOD. So thank you very much and have a nice day.